Guys, here we go. Here we go, guys. So, note 34. It says, let's review what's the difference between an indefinite integral and a definite integral. Relax, there's not much to it. A definite integral is defined, so it has limits. So, here's a definite integral. I'm just going to make one up, a very simple one. 1 to 3 of x squared dx. It is a definite integral. You do antiderivative, upper minus lower. So this would have been x cubed over 3. You're going to evaluate this from 1 to 3. You do upper minus lower. 3 to the third power divided by 3 minus 1 to the third power divided by 3. So let's see, what's that? 9 minus 1 third. 9, 3, 27. 27, 26. Sorry, guys. It took longer than it should have. Does 3 go into 26? 3. Nope. There it is. That's it. Yeah, that's it. That's the definite integral. What's an indefinite integral? An indefinite integral does not have limits. So I'll have this x squared dx. And you're just going to go x cubed over 3. And because there's no limits, I put what? Plus c. And depending on who your professor is, if you have a professor that's very picky, he might want to say for some constant c. For me, this is fine. Cool or not cool? Yeah, nothing crazy. It says evaluate an indefinite integral. This we've done many times. Hopefully by now we're pushing close to plus 100 antiderivatives. Antiderivative of x squared, that's x cubed over 3. And then antiderivative of negative sine x is going to be plus cosine x. And because there's no limits, you're just going to say plus c. And then you get a nice table of a whole bunch of different antiderivatives. Let's add one in here for chain rule. I guess let's do a quick review so that you guys can see. If I told you find the derivative of sine, give me your favorite constant. 3? I heard someone say 3. 3x. So what's the derivative of sine 3x? You would say cosine 3x and then times what? 3. Notice you have a constant there. So, what is the whole point of this? If I go into integral of 3 cosine 3x, you would say sine 3x plus c. I know you're still kind of confused. Like, I don't understand what you're trying to prove. All right, let's see if we can do this one, guys. Cosine 3x. We'll keep the 3 there. This is not related to the one on the top other than the fact that it's cosine 3x. So antiderivative would be sine 3x plus c. But notice, I need to have something here in the front. What am I going to put there? Not everyone at the same time. Why did I put a 1/3 and not a 3? Why did I put a 1/3?
Oh, because
Yeah.
if you were to find a chain rule, it would cancel out.
Perfect. Bro said it perfectly. If you were to do the derivative with chain rule, it would cancel out. Look, 1/3 cosine 3x. If I take the derivative times the derivative of 3x, which is 3, and 1/3 and 3 cancel each other out because I don't have a 1/3 in front of that cosine there. Do you guys see that? So let's go ahead and add a definition to this, and we can only do the ones that have a linear argument. So let me add. So I'm going to add to these two right here. So I'm going to say this. I'm going to write integral of cosine, and I'm going to write k for a constant. I know it's not the same as a c, but let's write k. Ku du is equal to 1 over k sine of ku plus c. Just whatever you have, take the reciprocal. Whatever you have, take the reciprocal. Because of chain rule. Because when you take the derivative of this, you want to cancel it out to get a 1 in the front. Do you guys see that? So same thing for this one. I'm going to write integral, sine, parenthesis, and I'm going to write ku, where k is some constant, du. I'm going to write negative 1 over k cosine ku plus c. There it is. Put that in there as part of these from the table. You probably saw them last night on Delta Math, and you were probably like, what the heck? Hopefully you figured it out. Okay. So there it is, guys. And I guess the same could be said with some of these, but there it is. Hopefully now we know. All right, let's go to, oh, yeah. We're good. All right, paying attention to the differential. We're getting really close to u sub. It says let f of x equals x cubed plus 1 and let u equals x squared. Find each of the following antiderivatives in terms of x. Okay, they said in terms of x. So this one's straightforward. I have my f of x right here. I'm just going to go integral x cubed plus 1. I'm going to put that in parentheses, dx. You don't have to have parentheses there, guys. Make sure you understand that sometimes authors just don't put the parentheses there. Antiderivative, so I'm going to write x to the 4th over 4. Plus, what's antiderivative of 1 with respect to x? X, and then I put a plus c. Nothing crazy. That's it. Look at letter B, because it wants everything in terms of x. It says, well, I got to be careful here. It says f of u du. Yeah, because sometimes, okay. So here we go. So f of u, guys, is just x cubed, u cubed plus 1. That's all it is. Whatever that function is, if you put a letter u in there, then they put that at the letter u. If you put a happy face, then you put a happy face. See? Whatever it is. So there it is. So I'm just going to rewrite this. I'm going to go integral u cubed plus 1, and then your differential, du. Bless you. Is anyone confused? Okay, what's antiderivative of u cubed with respect to u? Plus, what's antiderivative of 1 with respect to u? U. And I still have that plus c. Do they want it in terms of u, though? No. So I'm going to rewrite this in terms of x. Look what u is. U is x squared. So I can write, this is just put parentheses if it helps you out. Wherever you see a u, you're going to substitute it for x squared. X squared to the 4th power over 4 plus x squared plus c. So this is x to the 8th over 4 plus x squared plus c.
So like, can we just automatically substitute the x squared, or you have to?
No, on this, oh, like up here as soon as you do this? Yeah, that's fine. You'll still get this answer here. No, because this has a du here. So we're integrating with respect to u, not x. Yeah, as a matter of fact, here's the next one. So check it out, guys. Yeah, so this one we're going to have to replace it immediately. So this one has integral of f of u dx. So remember what we said what f of u was. F of u was u cubed plus 1. But can I integrate right now? No, I need to integrate with respect to what letter? X. So I need to change this. Chop, how do you change it? Let's see. I'm going to write right here. I'm going to say u equals x squared. That's what u is. It's right here up in the top. See? So I'm just going to plug it in. I'm going to plug this in. So that means the u cubed plus 1 is going to look like this. Put parentheses to help you out there. X squared to the power 3 plus 1. So laws of exponents, an exponent raised to an exponent, that's going to be x to the 6 plus 1. In case you don't know why you multiply them, guys, because I know maybe you just don't want to ask, remember that means this, x squared times x squared times x squared. Oh, look, it's a product. X squared times x squared times x squared, that's x to the 6. In case you don't want to ask and you are wondering. All right, so here we go. Integral. Parenthesis, x to the 6 plus 1, close it, dx. What's antiderivative of x to the 6? Over 7 plus x plus c. Don't ever forget the plus c, guys. Okay. Now I think we know the difference. Don't worry, we're not pros yet. Go to the next page. And I'm going to take a time out real quick. I know, so bear with me. I know some of you can just look at it and just do the antiderivatives really fast. There's probably about 4 or 5 you can just look at it and be like, the antiderivative of that is just this. If you can see it, you don't need to use U substitution. The whole point of U substitution is to make life easier. This one, some of you can probably see it because you see the cosine x on the top and you see a sine x and you know your chain rule of derivatives. But if you don't see what I'm talking about, chop, I have no idea what you're talking about. Look, check it out. I want to take the antiderivative of that. I see a cosine x here, I see a sine x, and I'm like, man, I don't know how to do that. Make it simpler. So it doesn't have any limits. I'm going to write on the side, I'm going to say, well, I'm going to do U substitution. Let's see, how can I make it simpler? If U equals cosine x, then du, I'm taking the derivative of u with respect to x. What's the derivative of cosine x? Negative sine x. Now from now on, guys, instead of writing du dx, which is correct, I'm just going to write it like this. Du equals negative sine x dx. Is that okay with you guys? All I did was this, times dx times dx. All right. Here's how I prefer. This is all a product. You can rearrange stuff as long as however you like. The dx is always the last thing because it's known as the end of your integral. So I can rewrite this. So don't write this down. Just listen. I can rewrite this like this: e to the cosine x times negative. Oh, well, okay. Let me write it as sine x because there's not a negative right now. Sine x dx, and that's the same thing, right? Like I haven't changed anything. Now notice, look what I have here. It says du is a negative sine x dx. Okay, here's where I'm not saying that I don't agree with delta. You can do delta's route. But now I think things are changing because some kids are learning just through delta alone and they're starting to do it that route. But most textbooks, I would think, do it like this. Not all textbooks. Delta doesn't do it like this. Let me tell you why. Have you guys taken chemistry? Do you guys remember when you would balance equations for equilibrium? If you had 3 oxygens on the right, you would do 3 oxygens on the left, and you would put all numbers like that. That's the background I come from. Chemistry was my first love. I love chemistry. And so here's how I do it. You see that negative? I'm going to force a negative on the inside. This is a product. If I force a negative in there, then I got to balance it just like in chemistry. So if I put a negative in there, I got to put what on the outside? A negative. See? So there it is for balance. And now look, for balance. Now this becomes way easier. Negative on the outside, integral. U is cosine, so e to the u. And negative sine x dx is all du. And look, isn't that way easier to evaluate? Yeah. Now you just gotta, what's the antiderivative of any e to the u? That's what we said. We did the u substitution. We set u equal to cosine x. No, if you would have set u equal, this is trial and error sometimes. If you would have set u equal to sine x, then du would have been cosine x dx, and there is no cosine x dx to replace. There's only a negative sine x dx to replace. Do you see what I mean? No? Okay. Is that cosine x? That's not cosine, that's a sine x. See, look, I replaced that equals du. So I replaced all this with du, and now look, e to the u du. And I can do this antiderivative really fast. That's just negative e to the u plus c. See, that's it. We're done. But notice that this was in terms of x. Are there any limits? Okay, then it was never about u. We got to go back to our x. So we're going to go negative e to the cosine x plus c. Yeah, if there are no limits, it's not defined, it was never about us. It was never about you. Go back to your x. Which is not good advice for real life. Never go back to your ex. But okay, don't worry. Look, we're gonna help you out right now. All right, did that kind of make sense? Maybe I should have started with this one. I thought that one would have been easy, but maybe this one's easier. All right, don't worry, guys. Look, check it out. Tom, I don't know how to do this antiderivative. Help me. Look for a pattern. Do you see on the inside I have a cubic, 2x cubed? Okay, hold on. You see how you have a 5 plus 2x cubed right there? If I take a derivative of 5 plus 2x cubed, will I get a square? Yeah, I will, right? 6x squared. not a perfect x squared, but I do. I get 1 degree lower, right? So check it out. Don't worry, guys. We're going to become experts really quick. I'm going to force my u because I want to do antiderivative. I want to do the antiderivative of this. So I'm going to go my u equals 5 plus 2x cubed. Are we okay? So here you go. I'm going to write du. If you want, you can write du dx and then multiply by dx. But so it can look cleaner, du is equal to 6x squared dx. Have I confused anyone? Okay. So check it out. Chop, how is this going to help me? I don't have a 6. Let's rewrite it. Integral, and I'm going to write square root. This is a product. Always put the dx at the end. 5 plus 2x cubed times x squared dx. And if you have colored pencils, it is a good one to do colored pencils. And of course, it's all this right here, right? All I did was expand it. Here you go. I'm going to take my colored pencil. I know that u is 5 plus 2x cubed, and I know that du is 6x squared dx. I like the chemistry route. Delta will not do it the chemistry route. Delta will have letters x's and u's in one line. I'm not a fan of that, guys. If you can do it correctly without making a mistake, you should be fine. At the reading, those are professors. Those are, but so I've noticed that if you have u's and x's, here's what I've noticed from all the years I've been teaching, that if you have u's and x's in your expression, you mess up somewhere with the variables and you lose your point. So that's why I like this route better, because you're not going to see u's and x's like in Delta, the way Delta does it. All right, check it out. Du is equal to 6x squared dx. Well, I don't have a 6x squared dx, but I can make it 6x squared dx by plugging in a 6 right here. Do you guys see that? Now, that's magic. If I put a 6 there, I got to balance it, just like in chemistry. What do I put on the outside? Remember, it has to equal 1. So I can't put a 6. I have to put a 1 6. Do you guys see what I did? So now look, now let's replace everything. This 6x squared dx, that's du. And this 5 plus 2x cubed, that's u. So now I can rewrite it like this. 1/6 integral square root of u du. Isn't that way easier? Okay, here we go. I'm going to turn that into an exponent. 1/6 integral u to the half du. That's still 1/6. 1/6, I'm going to put a little dot. I'm going to add 1 to the 1/2, so that's u to the 3/2. And divide by 3/2, which is the same as multiplying by 2/3, and I'll put plus c. I'm just going to reduce it. 2 goes into 6 3 times. 3 times 3 is 9. So here we go, guys. So I'm going to say integral. I'm just going to write this statement here. Integral of x squared square root of 5 plus 2x cubed dx is nothing more. I'm going to write everything in terms of x. 1/9, parenthesis, u was this. 5 plus 2x cubed, close it to the 3/2. And then I put plus what? Plus c. There it is. Do you see how we did it, guys? Don't worry, we're going to do a whole bunch. All right, look at example 5. I'll wait. Look at example 5, guys. Cotangent 7x dx. Chop, I can't do that. Yes, you can. Let's write it in terms of cosine and sine. Keep the argument. Integral cosine 7x over sine 7x with the dx right here. What do you think u should be? Should we mess up first? Should we do it wrong first? Don't write this down. Just listen. Let's say I say that u equals cosine 7x. That's wrong, by the way, but let's say I don't know any better. U is cosine 7x. So then I write du is negative sine 7x times 7. And then there's dx over here. Du dx. All right, look, guys. There's no way that you can replace it right now, because this sine 7x is in the bottom. Do you see that? You can't, there's not, like, you have to have a cosine 7x dx in the top to replace it with that du. So that is wrong, because there's no way that I can substitute that. because I have that -7 sine 7x in the bottom, and look, that dx is in the, like this dx is in the top, but that sine 7x is in the bottom. So this is wrong. I can't do it like that. See? So that means that u was sine of 7x, and now du, what's the derivative of sine 7x? Cosine 7x times 7. Make sure to put the dx on the outside like that. All right, here we go. I'm going to take my calculator. I'm going to take my pencil here. I'm going to change colors. I almost have cosine 7x dx. That's what I have. What am I missing? So I'm going to insert a 7 right here. If I do that, I got to balance it. What do I put on the outside? A 1/7. See? So now, here it is. I'm going to replace everything. 1/7 integral. That 7 cosine 7x dx is just du over, and then that sine 7x is u. Job, I don't know how to do the antiderivative of that. I don't recognize it. Okay, let me show you. Let's recognize it. Integral 1 over u du. Now do we recognize it? What's antiderivative of 1 over u? Starts with the letter L. ln. So 1/7 ln, absolute value of u, because there's no limits, plus c. But it was never about u, because there's no limits. We got to go back in terms of x. So I'm just going to rewrite this. I'm just going to go integral of cotangent 7x dx is just 1/7 ln, absolute value, and then plug back what u is. Sine 7x, close absolute value, plus c. There's no limits. The domain of ln is all numbers greater than 0. But since there's no limits, I could have x be negative, so you got to put absolute value. All right. Hopefully that's getting easier for you guys. We'll do some more until you feel that we can. All right. This is more for BC. What's up?
So whenever there's a fraction, is it like never the denominator that you substitute? Like, does it always be greater?
It depends. It depends. You're gonna see a whole bunch. You're gonna be seeing partial fractions and all that good stuff. We're ready to meet because now we've done velocity, distance, displacement. So we'll meet for sure this coming Monday. All right, here we go. I'm gonna rewrite this. So how are you gonna rewrite it? I'm gonna write it like this: integral 1. Okay, side note, I guess. Side note: 1 over cosine theta is equal to secant theta. That way you guys can just, hopefully we'll see it. I'm kind of on the fence on this one, on whether we need to use u sub, but if you see it, go ahead. You don't need to do u sub, but if you don't see it, I'm going to come to the side, and I'm going to say that u equals 2x. If u equals 2x, du equals 2 dx. Nothing crazy so far. I'm going to put a 2 right here. If I put a 2 there, what do I put on the outside? Not everyone at the same time. A 1/2. Yeah. You got to balance it out. You need to make sure that it equals 1. All right, here we go, guys. 1/2 integral secant squared u du. What's antiderivative of secant squared? Starts with the letter T. Tan. The derivative of tan is secant squared. 1/2 tan u plus c. And I know there's like a handful of you guys that are probably saying, I don't need u substitution for this one. And you're right. If you can see it, go ahead. 1/2 tan of 2x plus c. If you were to, Chav, how do you check if you're right? Take the derivative and see if you get secant squared 2x. And you do. Where's the what? Oh yeah, because I substituted. U equals 2x. I plugged in a u. The 1/2? It's right here. That's the 1/2. What 2? 2, yeah. 2 dx is du. I substituted, miss. Right? right? All right, check it out, guys. Cosine cubed x dx. So side note, just so we're all on the same page, cosine cubed x dx, or cosine cubed means cosine x times cosine x times cosine x. Real quick, just in case you forgot, Valentine's is, oh wait, we already passed Valentine's. Cosine squared x plus sine squared x equals 1. Hopefully you use that as in a poem for Valentine's Day. Yeah, you're a cosine squared, just give another sine squared, and together you're 1, right? And if they don't get it, break up with them. Upgrade yourself. All right, here we go. That cosine cubed, I'm going to rewrite it like this. Cosine squared x, that's a squared, times cosine x dx. Chav, why are you doing that? I'm going to replace the cosine squared. See, this is cosine squared. I'm going to rewrite this. I'm going to write cosine squared x is equal to 1 minus sine squared x. And that's what I'm going to substitute. So I have integral, parenthesis, 1 minus sine squared x, close it, cosine x dx. All this is a product. This is still like your f. Are we okay so far? So check it out. What am I going to make my u now that we've done that? No, not 1 minus sine. Not cosine. Sine x. Child, how do you know what to make? Okay. Yeah, I'm gonna help you. Check it out, guys. How do you know what to make your u? You see how cosine x dx is nice and pretty right here? When I take a derivative of sine x, I'm going to get a cosine x dx, which I can easily substitute for du. See? So if you would have made u 1 minus sine squared, you would have done chain rule, and you would have had 2 sine x cosine x dx, and then like it looks ugly. Like there's not, like, you know what I mean? So now look, du equals cosine x dx. Look, nice and pretty. Cosine x dx is right there. That is just du. All right, guys, focus. So here we go. Integral, parenthesis, 1 minus u squared, close it, du. Look how pretty that is. That can be done really fast, I hope. What's antiderivative of 1 with respect to u? No, not x. U. What's antiderivative of u squared with respect to u? U cubed over 3. And then put the plus c. I have no limits. I have to go back to the x. Yeah, I know. It hurts me every time I say that. So it's going to say sine x minus sine cubed x over 3 plus c. Yeah, don't go back to your x. That's just bad. Cool or not cool? No, with Math Life. Okay. All right. Here we go. All right, here we go, guys. Now we have a definite integral. You have limits. You have limits on this integrand. Because you have limits, you're not going to go back to your x. This time it is about u. So I'm going to create a different integral that are going to be equivalent. And guys, the whole point of this is to make life easier. So you're not going to go back to your x. You're not. So check it out. What am I going to... You see a 10x and you see a secant squared. I bet you're going to be able to figure out what u is. What am I going to make u? Yeah. Ms. Rowe, tell me why you chose u to be 10x. You're not anti, but derivative. The derivative, right? The derivative of tan is secant squared.
Yeah, well, I did it back in secant squared. I did the antiderivative.
Got it. Yeah, the antiderivative of secant squared. Perfect. All right, so there it is, guys. U equals 10x. Du equals secant squared x dx. Look at that. It's going to turn out, it's looking beautiful. I put my integral symbol. This is u and this is du. So there's just going to be u du. Do you guys see what we did? Now I need limits. Guys, we're not going back to the x. Here we go. When x is 0, what is u? I'll just plug it in right here. What is tan of 0? 0. So that limit looks like it's still the same. But now check it out. Pi over 3. You need a little bit of pre-count, not that much. What is tan of pi over 3? Do you guys remember? Yes, square root of 3. Good job. For those of you that are not sure what I'm talking about, here's the unit circle. Here's pi over 3. At that coordinate, that is 1/2 comma square root of 3 over 2. Tan is y divided by x. So square root of 3 over 2 divided by a half is just square root of 3. So I put square root of 3 in the top. Do you guys see what we did? There is no reason. Okay, I need to emphasize this 100%, guys. There is no reason to go back to your x here, guys. No reason. This is equivalent to this integral. They're both the same. So there's always one that's going to go back to the x. Don't. Now stop doing that. And in life as well, too. So just do the antiderivative of that right there, guys. So here we go. Antiderivative of u is u squared over 2. I only have one term, so it's fine if I don't put a bracket. That line means evaluate, just like in computer science. I put a 0 in the bottom. I put a square root of 3 in the top. Upper minus lower. We don't care about the 0. Square root of 3 squared over 2. And that's it. 3 over 2. What do you guys think? Not bad, right? All right, check it out, Salali. Hook me up with what do you think u is on this one? Look at the numerator and look at the denominator. How are they related? If I take a derivative of the denominator, do I get 1 degree lower? Let me ask again. See how that's x to the power 1? If I take the derivative of the denominator, will I get x to the power 1? Like as an expression. I know that there's going to be a coefficient in there. Will the derivative of x squared minus 4 be 1 degree lower? Yeah. So my u is going to be all of this. Don't leave off the 4. Make life easy. U is equal to x squared minus 4. So du is equal to 2x dx. You're not going back to your x. Here we go. I'm going to put my colors here. I need a 2 in the numerator. If I put a 2 right here, what do I put on the outside? 1/2. There it is. Perfectly balanced. Like all things should be. Thanos. Yeah, okay. I'll stop. Thanos wiped out half of the... All right. 1/2 integral. I'm not putting you limits. The 2x dx is du. I'm going to rewrite it like this. 1 over u du. You can put the du in the top. That's fine. But I find it, you guys see that it's easier like this. Are we still okay? All right. When x is 0, what is u? Plug in a 0 in here. 0 squared minus 4. That's going to be -4. So put -4 as your limit. See, now here comes the absolute value. When x is 1, what is u? 1 squared minus 4, that is -3. Do not go back to the original, to the x. This is equivalent. They're equivalent, guys. I'm going to stay with this. Here we go. Antiderivative. 1/2. I'm going to put dot. I'm going to put a bracket. What's the antiderivative of 1 over u? ln. Put absolute value of u. Close it. -4 to -3. We're going to do upper minus lower. Leave the 1/2 factored out. Make life easier for yourself. Because, both terms are going to have the half. Just leave it on the outside. 1/2 bracket ln absolute value of -3 minus ln absolute value of -4. Close, close. Absolute value of -3 is 3. Absolute value of -4 is 4. I'm going to write it in one swoop. 1/2 ln 3 over 4. Chav, can I make it a square root and make it ln of square root of 3 over 2? I guess you could, but there it is. Are we okay? Oh, yeah. Do we know the properties of logs, the three main ones? Okay, write them down, guys, real quick. I'm going to put side note here. I'll do it in black. Side note. All right. Log, or it doesn't matter. Log, I already wrote log. Log A minus, that's an A, not a 9, minus log B is equal to log A over B. Log A plus log B is equal to log AB, because logs are just exponents, guys. And then let me see, C log A is equal to log A to the power C. All right. Oh. All right, here we go. Don't worry. This is the last page. Let f be a function such that from 9 to negative 18 of f of u du equals 3. You got to be careful with that. I don't know why they... Okay, anyways. What must be the value of the integral from negative 6 to 3 of f of 3x dx? Okay. You guys ready? So I'm gonna turn this and see if I get that. So I'm going to go integral negative 6 to 3 of f of 3x dx. They're telling me what my u is, kind of. See? I'm going to come to the side. I'm going to say u equals 3x. So du equals 3 dx. Have I freaked anyone out? I'm going to take my colored pencils. You can put the 3 in the front of the f of 3x, but I'm going to put it right here because we're rookies. Look, that 3 dx is just du. So I'm going to start rewriting. Integral, I know that I'm going to have u limits. F of u du. Okay, catch up to here. Does everyone know what we're doing? Well, it's because I got two Hernandez's. Hernandez and Hernandez. All right, here we go. What's up? Oh, you're right. If I plug in a 3, man. If I plug in a 3, yeah, let me go to this. If I put a 3 there, then what do I got to put on the outside? 1/3 to balance. I was testing you. Chemistry. I would have gotten it wrong, and I would have been like, what's wrong? Okay, thank you. All right, I think we're good now. No harm, no foul. All right. Put a 3, put a 1/3. Perfect. Everything's good. All right. When x is negative 6, because this was in terms of x, what is u? So what is 3 times negative 6? Negative 18. When x is 3, what is u? What's 3 times 3? 9. OMG, look at this. I know that this right here is equivalent to this guy, right? That's what they want to know. They want to know the value of that. And look, I already know that f of u du is equal to 3, this guy. So all I got to do is, how do I get rid of that 1/3? Yeah, multiply by 3. So I'm going to go, okay, Chav, what are you talking about? I don't know. Look, let me circle. This right here that I'm circling is equal to 3. And I want to make sure that you guys understand this. This integral with the 1/3 included is equal to this. Or they're equal to this guy, with like that, without the 1/3 in the front. Those are equivalent. So all I got to do is replace that with the 3. So what's 1/3 times 3? And that's what this is. What happened? Tell me. Did I mess up? Oh, I plugged it in right here to get my x values. Because this is in terms of u, and this is u equals 3x. So if I want my limits in terms of u, I plug it in right there. See? Yeah, the x was negative 6. So I plugged in a negative 6 to get my u value. And then this guy right there, that's 3. So I have 1/3, which is this 1/3, times 3. That makes sense? Okay. No, that's it. Let me see. Yeah, because this, from negative 18 to 9 of f of u du is 3. And I want to know what this is. So I just got a 1/3 times that 3. Hold on, let me see. Hold on. Does something feel funny? This expression, hold on, guys. I gotta see. Yes. This equals. Okay, yeah. Let me make it better. Sorry, guys. I think we're good. Let me see if I can erase some of this. So, no, you don't have to erase anything. This expression here, with the 1/3, is equivalent. This is equivalent to this. Those are the same. So yeah, because we just remember we changed our u's and 3's and all that good stuff. So then, so I got a so I. All right, hold on. Hold on. I plugged in my 3 so I can balance it out, 1/3. And then I did it in terms of u. 1/3 from negative 18 to 9 of f of u du. No, it's 1. Yeah. Yeah, because this right here is 3. So 1/3 times 3. We're good. I'll do one on delta just in case. All right. Last one, guys. Last one. All right. Check it out. What do I do? What's my u? Why is your u 9 minus 5x cubed? All right, guys. Focus. Grandpa, grandma. All right, guys. I get a negative 15x squared dx, and you see a 3x squared. So how do I turn a 3x squared into a negative 15x squared dx? If I multiply this by negative 5, then I put what on the outside of the integral? Negative 1/5. So now it's going to look like this. Integral. You still have that 2 in the bottom. So you're going to have u square root of u du with a 2 in the bottom. That 2. Are we okay, guys? Make life easier. Can I take that 2 out of there? It's a constant. Yeah, you can. Negative 1/10 integral square root of u du. Is anyone freaking out? What happened? No, u is equal to 9 minus 5x cubed, and du is negative 15x squared. So I have to multiply by negative 5, so I put a negative 1/5 on the outside. And then that 2 comes out, negative 1/10. I guess I could have also put it on the out. All right, here we go, guys. Here we go. When x is 0, u is 9. When x is 1, 9 minus 5 is 4. Oh, they're making it nice for us. They're making it real nice for us. Look at this, guys. You see how the upper limit is 4 and the lower limit is 9? I can flip them. And when I flip them, what happens to that negative? So 1/10 integral 4 to 9, of u to the 1/2 du. Cool or not cool? All right, we're done, guys. 1/10 times, leave a little bit of space, add 1 to the exponent. 1/2 plus 1 is 3/2, so u to the 3/2 divided by 3/2, which is the same thing as multiplying by 2/3. Don't put plus c. This is evaluated from 4 to 9. Yeah, pause. I'm waiting. Divided by 3/2, which is the same as multiplying by 2/3. 3/2. All right. Make life simple for you guys. I've been seeing on some of the FTOCs that you turned in, some of you keep the coefficients with your u's. That's fine, like upper minus lower. But guys, think about it. Those are the same coefficients that are going to be on both terms, so just factor everything out. So let's see. 2 goes into 10 5 times. 5 times 3 is 15, so factor it out. I'm going to write 1 over 15. See? Times, and I'm going to do upper minus lower. 9 to the 3/2. Oh, okay, we're going to talk about that. Minus 4 to the 3/2. Relax. If you have no calculator, guys, these have the same weights. Remember from your algebra 2, the laws of exponents. If you choose, you can do the cubic first, the cube first, and then do the square root. But it's easier, in my opinion, to do the square root than cube. What's the square root of 9? And 3 to the 3rd power? 27. So that's 27. What's the square root of 4? 2. And 2 to the 3rd power? 8. 27 minus 8. So do 1 over 15. 27 minus 8. So that is, what is that? 19 over 15. There it is. How do we feel? All right, take a little break. There is no delta, at least not yet. I have a paper assignment. But it's short. It's a 1-pager. All right, guys. I'm going to do number 4. Hopefully, after we do number 4, you will truly understand what we're trying to... Make sure that you're focused on the big picture, guys. What are we trying to do? We're trying to take an antiderivative of something that looks complicated and make it look simpler. Cool or not cool? So look at number 4. They tell you what the u is. This is us helping you out. So then I'm going to write du is equal to 4y cubed plus 8y. And then dy, put it in parentheses like this. Chav, where did that come from? Because some of you are asking, remember in the very beginning I said du dy and then times dy times dy. That's why I'm just writing this to save maybe a few seconds there. All right. I know, Chav, I don't see this in here. Why do I do it? Factor out a 4 out. Look, du equals 4 parentheses y cubed plus 2y dy. Now check it out. I see it right there. Y cubed plus 2y dy. I see an 8 in the very front. You can turn that 8 into 4 times 2. So look, here I am. I'm just rewriting it. I'm going to put the 2 on the outside. Integral y to the 4th plus 4y squared plus 1, close it squared, times 4 parentheses y cubed plus 2y close dy. Chop, I don't understand what you're doing. I just rewrote it so it's easier for you guys to see. You don't have to do it this way. Once you become a pro and you see it, oh, I'm going to use one of those 4s. That 2's still there. That's all a product. I can put that 2 on the outside, but if you don't like that, you can leave it on the inside. It's whatever you like. You can do whatever you like. Okay, anyway. That 4 parentheses y cubed with 2y dy, that is just what? du. So I can just substitute it, and that y to the 4th plus 4y plus y to the 4th plus 4y squared plus 1, all that squared is just u squared du. Do you guys see what I just did there? Let me know, guys, because I can't read minds. Are we okay with that? See, all this right here, this is all du. That's all du. Put the du at the end because it's known as the end of your integrand. So here it is. 2 times, what's the antiderivative of u squared? U cubed over 3 plus c. Do I want it in terms of u or in terms of y? In terms of y. So we're going back to our x. So here it is. So this equals 2/3 parenthesis, what's my u? Y to the 4th plus 4y squared plus 1 to the power 3 plus c. It's okay if you put an equal sign because they're equivalent. Ask me, Lopez. Did you get the same answer? Yeah, I'll look at yours right now.